Hello friends, the topic for today is 8255A Programmable Peripheral Interface Architecture. The microserver communicates with the outside world through I/O devices. In microserver system, we have peripherals such as keyboard, switches and mouse that provide binary information as input to the processor. Similarly, we have output peripherals such as monitor, printer, liquid crystal display, LCD panel and LED that accept information from the processor and display it. The peripheral need to be interfaced with the microprocessor through I/O interfacing chips known as I/O ports. 8255A is a programmable peripheral interface IC and a multi-port input-output device. It is general purpose programmable I/O device for use with microprocessor 8085, 8086, 8088, etc. In today's video, you will learn the architecture of 8255A with its block diagram and pin diagram. Let us start. Welcome to our channel Engineering and Technology for You. The topic for today is 8255A Programmable Peripheral Interface Architecture. Let us start with the introduction. The 8255A is a general purpose programmable I/O device designed for use with microprocessors. It has 24 I/O pins which may be individually programmed in two groups of 12 with and used in three major modes of operation. So 24 I/O pins which may be programmed individually into two groups of 12. So there are two, group A and group B, and there are three major modes of operation. So let us see the first mode. In the first mode, that is mode 0, each group of 12 I/O pins may be programmed in sets of 4 to be input or output. Then in mode 1, the second mode, each group of may be programmed to have 8 lines of input or output. Of the remaining 4 pins, 3 are used for handshaking and interrupt control. So mode 1 is used for handshaking. Then the third mode of operation, that is mode 2, is bidirectional mode, which uses 8 lines for the bidirectional bus and 5 lines, borrowing one from the other group for handshaking. So this is particularly for port A only, which uses the bidirectional mode. Then let us see the features of 8255. It is 24 programmable I/O pins are there in 8255. Then it is completely compatible with TTL. Then direct bit set reset capability. So it has the capability to set or reset the bit directly. Then improved DC driving capability. So it is providing sufficient current for driving the load. Then 40-pin dual in-line package. It's a IC available in 40-pin dual in-line package. Then let us see the block diagram of 8255. So the first block is the data bus buffer. So this is a bidirectional buffer and it is connected with the data bus. Then second block is the read write control logic. It has the signals for read write operation and then the address lines A0, A1 and reset, and also it has one signal for the chip select CS bar. Then we have two groups, group A control and group B control. So these two control will control the particular ports. So group A will control group A port A and group A port C upper. Whereas group B control, it will control the group B port B, that is PB0 to PB7, and group B port C lower, that is PC0 to PC3. And these are the internal buses, data bus, internal data bus. Then we have the power supply plus 5 volt and ground signals are shown here. So this is the block diagram. We'll now see the description of the block diagram. General. Here 8255 is a programmable peripheral interface, that is PPI device, programmable peripheral interface, designed for use in microcomputer system. So any microprocessor based system, it is a microcomputer system, so it can be used for the microprocessor based system. Its function is that of a general purpose I/O component to interface peripheral equipments to the microcomputer system bus. So that is the main purpose or function of the IC. The functional configuration of 8255 is programmed by system software so that normally no external logic is necessary to interface peripheral devices or structures. So when we are interfacing the peripheral devices such as keyboard, display or LED, at that time no other external logic is necessary. Then let us see the next block, data bus buffer. This 3-state or tri-state bidirectional 8-bit buffer is used to interface 8255 to the system data bus. Data is transmitted or received by the buffer upon execution of input or output instructions by the CPU. Control words and status information is also transferred through the data bus buffer. So data, control word and status, these three things, they are transferred through the data bus buffer. It is connected to the system data bus D0 to D7. Then next is read write control logic. The function of this block is to manage all of the internal and external transfers of both data and control or status words. So it accepts input from CPU address and control buses and in turn issues command to both the control groups. So that is the main function of the read write control logic. It will issue command to both the control groups, group A and group B. Then let us see the group A and group B controls. The functional configuration of each port is programmed by the system software. In essence, the CPU outputs a control word to the 8255A. The control word contains information such as mode, bit set, bit reset, etc. that initializes the functional configuration of the 8255A. Each of the control blocks, group A and group B, accepts command from the read write control logic. That is what we have discussed. It will accept the command from read write control logic, receives a control word from the internal data bus and issues the proper commands to its associated ports. So control group A, it will control the port A and port C upper, that is C4 to C7, and control group B, it will control the port B and port C lower, that is C0 to C3. The control word register can be both written and read as shown in the address decode table in the pin description. So we'll see how it is written or read. Then let us see the ports A, B and C. The 8255 contains 3 8-bit ports A, B and C. All can be configured in a wide variety of functional characteristics by the system software but each has its own special feature to further enhance the power and flexibility of 8255A. So port A, so one 8-bit data output latch and buffer and one 8-bit input latch buffer. So output as well as input both are latched. Then similarly port B, one 8-bit data input output latch and buffer. Then port C, 8-bit data output latch buffer and one 8-bit data input buffer, no latch for input. This port can be divided into two 8-bit ports under the mode control. Each 4-bit port contains 4-bit latch and it can be used for the control signals outputs and status signal inputs in conjunction with the port A and B. So this we have discussed. In mode 1 and 2, the port C is used for the handshaking and other signals. Then let us come to the 8255 pin diagram. So as you can see here, the 8255 is a dual inline package 40 pin IC. So 20 pins on this side and 20 pins on this side. So here we have port A, PA0 to PA7, that is on this side. Then port B, it is PB0 to PB7, here it is situated. Then port C lower is here, P0 to PC3 and PC4 to PC7, that is the port C upper. Then we have the data bus D0 to D7. Then we have address lines A0, A1. Then other signals read bar, CS bar, write bar and reset. Then we have the ground and the VCC signal. So these are all the 40 pins of 8255A. Let us see the pin description. PA7, PA0. These are 8 port A lines that act as either latched output or buffered input lines depending on the control word loaded into the control word register. So we can use port A as input or output depending on the control word. And similarly the port C upper, PC4 to PC7. Upper nibble of port C lines, they may act as either output latches or input buffer lines. This port also can be used for generation of handshake signals in mode 1 and mode 2. This is what again the same point of discussion we have done. Then PC0 to PC3. These are the lower port C lines. Other details are same as PC4 to PC7. Then these are 8 port B lines which are used as latched output lines or buffered input lines in the same way as port A. So the port B can be used in the same way as port A. Then the lines D0 to D7. These are the data bus lines. Those carry the data control word to or from the microprocessor. So they are bidirectional. Then the next signal is reset. Logic high on this line clears the control word register of 8255. All ports are set as input ports by default after reset. So that is for the reset of 8255. Then read bar signal. This is the input line driven by the microprocessor and should be low to indicate read operation to 8255. Similarly, we have WR bar. This is again the input line driven by microprocessor. A low on this line indicates the write operation. Then chip select CS bar. This is the chip select line. If line goes low, it enables 8255 to respond to the read and write signals. Otherwise read and write signals are neglected. So this means the chip has to be selected in order to read or write. Then the lines A0 and A1. These are the address input lines and they are driven by the microprocessor. These lines are used for addressing any one of the 4 registers. That is the 3 ports A, B and C and a control word register. So control word register where the control word is written. So these lines with read bar, write bar and CS bar define the operation of 8255. Let us see the basic of input output operations. So here we have read bar, write bar, CS bar, A1 and A0 lines. So when read bar is low, that is the read cycle. So that's why we are written here input read cycle. Then write bar at that time should be high. Then CS bar it should be 0 for the chip select. Then 0 0 when A1 and A0 are 0 0, port A to data bus. So here we are reading port A. Then 0 1 we are reading the port B. 1 0 we are reading the port C, and 1 1 we are reading the say control word register. So here at that time it will be the status signal that is read to the data bus. Then the next, that is the output write cycle. So here WR bar is 0 and read bar is 1 and CS of course it has to be 0. So 0 0, so data bus to port A. So we are writing here data to port A. Then 0 1 data bus to port B. Data is written to port B. Then 1 0 data bus to port C. And 1 1 data bus to control word register. So when we want to set the mode of the 8255, at that time we'll make use of this data bus to control word register. So input and output cycles, they are working in this way, but when CS bar is 1 at that time, the other signals they are don't care. So that is bus is tri-stated. And when CS is 0 but both RD bar and WR bar they are 1, again these signals are don't care and the data bus is tri-stated. So this is how the 8255 basic input output operation will take place. So with this we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Instagram and the Gmail. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And if you want to get notifications for future videos, press the bell icon. Then thanks for watching. Have a nice day.